Okay, hello. I'm Forbes. I work for Facebook, but I only recently started, so you probably don't try and ask me too many questions about that. Today I'm going to be talking about GitHub automation. So I'm going to tell you a little bit of a story about a website called ES-Discuss, and this is how I got into the process of trying to automate functionality on GitHub. GitHub is a tool that I use every day, probably many of you use every day, and therefore I'm really passionate about trying to make the most of that tool and get the most I possibly can out of it. So this is a screenshot of the ES-Discuss mailing list archives. So ES-Discuss is the mailing list on which the next version of JavaScript is discussed, spec issues, what should the functionality of each operator be, what should the exact syntax be, and it has on that mailing list all of the major browser vendors, but also many of the developers who use JavaScript every day. So it's the perfect place to discuss these issues and be heard. Unfortunately, the archive is a horrible, horrible thing to read. No one wants to read that. It's one message per page. It includes a whole load of gumph on it that you don't care about. It's in a horrible monospace format that's hard to read. What you really want to read is something modern like this. So this has, the title as a nice big main thing. We have an avatar for the user who sent this message. We also have the, is this microphone still working or is it going a bit wrong? Okay. It also has the many messages with syntax highlighting for the code. It has, it has the code itself in a monospace format, but it has the rest of the text in a nice, plain, readable font. So this is a nice improvement. Now, when I was building this site, just use the mic. Yep. This one over there. Okay.
It's going to be on soon.
Hello. Hello.
Just a second. All right.
Hello. 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 Okay. Is that working now?
Yep.
Yep. Okay. That's better.
You can use this one if you want for a prop.
I think I'll probably leave that one.
All right.
That doesn't look terribly useful. Okay. So when I was building this site, I started out trying to build the simplest thing that would make the ES-Discuss mailing list archive more readable. So I built a static tool, a command line tool that would read in the Piper mail archive, parse it, and generate a load of HTML. The issue was it was slow to see the changes that I was making to any of the rendering logic because I had to reparse the entire archive before I could see anything. I only had one post per page, and it was difficult to really fix that without some kind of database to store the indexing of the messages. And there was no ability to edit the messages. This was a fundamental thing that I wanted to support, because sometimes when people are sending messages to mailing lists, they're really careless about how they format it. So it doesn't end up looking nice and clean and easy to read. So I wanted to be able to allow trusted users to edit messages to fix formatting issues and then have some kind of peer review process on that. So I fixed the speed to see changes by trying to do everything on request. That, of course, doesn't allow me to, because I have no indexing of the messages, there's no easy way to show multiple messages on a page. So that idea is scrapped. Let's move past that. So I mentioned this editing functionality is really core to what I wanted. I wanted collaborative editing. I wanted to be able to see the history of changes. I wanted some kind of peer review process. So GitHub seemed like the ultimate choice for storing these messages. Not only that, but all of my data was public. So GitHub represented free, unlimited storage, as well as this great moderation tool. So I built a system somewhat like this. There was a bot that sat in the background, pulled changes off of the Piper mail archive of ES-Discuss, the official archive, placed them into GitHub as files, and also placed an index into the database. And this actually worked pretty well. It allows you to edit the messages as they come in. It allows anybody to submit edits to the messages, and then a trusted core group of users to review those edits. Because of the database, it was easy to have multiple posts per page. And like I say, there's great support for editing. Unfortunately, GitHub is really slow as a database to read from. Don't treat GitHub quite like a database. It's not a great idea. This was fantastic as a proof of concept and as a demo, but it was too slow to really treat as a production application. So I considered two approaches to building this. The first was a simple approach of trying to use the Git command line tools and automate those. At the time, I was trying to run it on a VM that I had very little access to, so I couldn't even install Git on that server, which I realize is a stupid restriction to build an application around, but that's what it was. The other problems I had, though, were more legitimate issues. I needed to be able to create repositories automatically on demand, and there's no way of doing that from the Git command line. I create GitHub repositories. And I also wanted to be able to add content to a GitHub repository without first having to fetch the entire GitHub repository locally. And that's very, very much easier to do via the API than it is via the command line. So I used the API. Unfortunately, GitHub have no single API that, or at least didn't at the time I looked at this, to make a multi-file commit. So you take many updates to a GitHub repository and you want to commit them in one go. That's actually really hard to do using the GitHub API, and we'll have a look at how exactly you go about doing that later. But it had the advantage that there's no dependencies to install because it's just a curl-based API, it's a REST API. And you can do anything you can do on GitHub, you can do via the API. You can create repositories, you can delete repositories, you can close and open issues, you can comment on issues, you can merge pull requests, you can do all sorts of things. So as I mentioned, GitHub was too slow, so I ended up taking a different approach, and now this system runs with its own actual dedicated database. But let's ignore that, and let's talk about what we really came here for, which is using the GitHub API. So I'm sure you're all wanting to know, how do you get started using the GitHub API in order to automate tasks on GitHub? Well, GitHub has a really beautifully designed REST API. You can see the documentation at developer.github.com. All of your API requests go to api.github.com, and the only real caveat that I found catches me out and confused me to begin with is that when you mess up authentication, you tend to get a 404 not found error rather than the correct 403 forbidden error. And the reason for this is that they don't want to allow you to see whether a repository exists or not just by pinging all of the possible repository names. So they just return a 404 whenever authentication fails, because that way you can't get any extra information out of, you can't distinguish between a repository not existing and you not having access to a repository. So that's the one thing to be aware of. So with that in mind, the simplest way to get access to the GitHub API is to go into settings and then applications and then generate a new token. So this is the ideal way if you're just running like a one-off command line script, or you've got some bot and you just want to have some code be able to behave as that user, as that bot. Then go in, log in as your bot, and generate a new API token for it. If you want to have some website that other people can sign into and use to interact with their own GitHub account, then you'll need to go to that register new application button, and then through that you can set up standard OAuth stuff, and it's just a normal OAuth sign-in process. Once you've clicked on that button to generate a new token, you can choose the permissions you want. So you can tick all of these if you want, and then you'll be generating a token that can do absolutely everything that you could do. Or you can tick just the specific things that you need, and I'd highly recommend you do that because it's very easy to accidentally commit a token to some public GitHub repository, and then you find that you've given the entire world the ability to do absolutely anything on your project. So if all you want to be able to do is automate following and unfollowing of users, then you can just tick the user follow button, and then people have pretty limited access even if you accidentally leak one of these tokens. And obviously if you do leak one of these tokens, you can just delete it, and then that becomes useless as soon as you've deleted it. So now that we've got our token, how do we actually make requests? Well, the way I tend to do this is using a library I wrote called GitHub Basic. And all this does is take care of authentication for you. It's a very simple, thin wrapper around the basic methods. So you've got, you need to pass the version of the GitHub API that you want to request from, and GitHub support their versions for a little while, so this means your app won't break as soon as a new version comes out. You need to provide the auth token that you want to use, and then one of the neat tricks GitHub Basic supports is that it allows you to make synchronous requests. If you're in a production environment and you're writing a Node.js web app, you want to make async requests, so don't set sync to true in that case. But if you're running some one-off command line utility, then really you're not caring too much about performance, and it's just easier to work with the API if it's synchronous. If you set that to false, then all of the API methods are going to return promises rather than returning the direct value that you want, and you'll have to then wait for those promises to be resolved and go through that process. But for now, we're going to assume that you're just running like one-off scripts or scripts where the performance isn't really an issue, and we've got sync set to true. Having done that, you can call get, delete, post, patch, and put. And you can provide that with the path of the GitHub API that you want to request and the various query parameters that you want to give it. And the GitHub Basic client will know whether to put those query parameters in the body of the request or as a query string parameters on the URL or as part of the URL itself. So I promised you earlier that I would tell you how to make a multifile commit in GitHub, and this function is the code to do it. So GitHub does not expose a nice, clean, simple API that says just make a new commit. Instead, it exposes you all of the stuff you need to interact with the underlying data model of Git. So if you know a little bit about Git and the data model within Git, then this should make perfect sense. And if not, it might be a bit confusing. I'll just run through things quickly, but you don't need to worry too much about this if you just want to get stuff done. So the first thing we do is fetch the head of the GitHub repository that's currently on the server. So this gives us the SHA of the commit that is pointed to by the branch pointer that's on that server. Having done that, we can then get the SHA of the file tree. So Git is structured as branches are pointers to commits, and commits are messages plus pointers to previous commits plus pointers to the state of the file tree at that point in time. So now we've got the SHA of the latest commit, we've got the SHA of the file tree at that state, and then we can upload the new file tree by saying base it on this old file tree and add these updates to it. So that's this script here, the new tree there. And then having done that, we can create a new commit, and we can say base this new commit on the old commit, so that's the parent's SHA latest commit, and we can say point the commit at the tree that we've just created, because we've got the SHA hash of the tree that we've just uploaded. And then finally, having done that, and this is the point that actually commits the code into GitHub, we can update that branch pointer to point at our new commit. And if we leave force as false, which should be your default, then that command might fail in the case that some other commit has happened in between, in the middle of this process. But if you set force to true, then you can just overwrite anybody else's changes, which is kind of nasty. So that's what that force parameter is doing there. Alternatively, if you don't want to care about any of that stuff, GitHub Basic includes a commit method that just accepts a repository name and an array of file paths and bodies to update. Okay, so time for a quick demo. Because I never trust conference Wi-Fi's, etc., I have done this as a video. So I'm going to talk over the top of it. So this is the Jade GitHub repository. what we're going to do is look at how we can interact with that via GitHub. So you can see that there's a button here that takes us to the contributors. We can get a list of the top contributors of this repository and see perhaps who is the most active in committing to the Jade GitHub project. If we wanted to build some kind of dashboard with that data on it, though, we'd want to go to the API rather than the website. And if we go to the API docs, we can see that there's a contributors API endpoint that we can call. We can see that it's a get method that it expects. We can see that the path is that repo/owner/repo/contributors. There's a parameter that is a true or false for a none, and we can pass that and get some results. So we use the GitHub client. I've set it up to say it's version 3 that I want. I've enabled file-based caching, which just saves a lot on bandwidth if you end up making the same request again and again. And I've loaded my authentication token from a text file just because I didn't want to display it on the screen today. I've set sync to true, just for simplicity. And then I'm getting that list of contributors. You can see the path from before that we saw in the docs. I've just copied that straight through. And I've passed in owner, repo, and anon as the 3 parameters that I wanted. And I've said I do want to include anonymous contributions. That API is going to return an array. And then I'm going to map over that array and print out a string that is the contributor, the number of contributions that the person has made, followed by their login name. And then I've just logged that out to the console. Obviously talked for less time than I planned to here. There we go. So I can see if I run that using Node that I get this list of contributors out. OK, so back to trying to make a commit. If we consider this test repository that has a README that says blank README, we can update that using the GitHub client in very much the same way as I described earlier. So this is the code to do that. I've called the client.commit function with the username and the repository name, the message I want the commit to have, and the list of files I want to update, and the new content. So I actually wrote this for a previous talk in which I was presenting at DDD East Anglia, so that was the content I used for that string. I'm sorry I haven't updated this video. So I run that, and it'll take a few seconds, bearing in mind it's going multiple round trips to the server to make that commit. But if I refresh the page, we can see it's updated the README. So that works. OK. Might need to refresh that because that's gone slightly wrong. OK, so that's we've seen one use case for GitHub, which is to try and use it as the backing store for a whole application. That's perhaps at the extreme end of what you might try and do with GitHub. What about using it in your day-to-day life? So I maintain Jade, and we recently made a breaking change. Well, I say recently, a few months ago. What we did was we removed shorthand syntax for the doc type. So as you probably most of you are aware, HTML has a doc type at the top of it, and you're expected to put doc type HTML at the top of your document so that browsers know to treat that code as a document. Jade used to have a ridiculous shorthand for that, which was 3 exclamation marks and the number 5. It's a very short thing to type, which is nice, especially given that you type it at the top of every document. But on the other hand, it's hopeless for a newcomer to read. No one who's completely new to that is going to read that and know what it means, whereas someone who reads doc type HTML can have a really good guess as to what that code is actually doing, what it's there for. So we made this breaking change, and several angry people complained. You can go to that URL if you want to read some comments by some angry people whose world was destroyed by this change, their entire lives ruined. And since they were so clearly so upset, I set out to see what I could do to help them. Well, it turns out you can automate the process of fixing code that relies on this deprecated feature with a function just like this. So this takes the string of some file and does some simple regular expression replacements to say, anywhere where you see 3 exclamation marks and the number 5, put doctype HTML. And it also catches a few other similar syntaxes that we deprecated at the same time. So I could have just sent that code to people and said, run this against your files, and then you'll have had everything updated, and that'll be fine. And in fact, I did publish this code somewhere so that people could run it themselves if they had private repositories that used this syntax. But I also figured that there were lots of public examples out there that were now going to be out of date. Both open source websites that happen to use Jade, but also places where people had just put Jade and built Jade websites as examples of how to use Jade. And those are places that beginners might go to see what the recommended syntax is. And I didn't want them to see the old out-of-date syntax. So I wrote a bit of code. This is a GitHub bot, and it is the process it goes through is given a GitHub repository to run against. It will fetch every repository, every public repository of everyone who has starred that GitHub repository on GitHub. It will download them one at a time, and it will run some code against that GitHub repository. And the code in this case that I chose to run is this body of code here, which will first look for any Jade files. If there are none, it will skip that repository. If there are some Jade files, then it will attempt to fix the doc type on each of those files. And then it will see if that resulted in any changes. And if it did result in some changes, it will fork that GitHub repository into an organization called JadeBot1. Then it will commit to that repository. It will create a branch called fix.doctype on that repository. It will commit onto that branch with the message fix use of deprecated Jade features and update Jade. And then it will create a pull request back to the original repository with that original owner, repo name, and whatever branch was the default branch on that repository. And having run this code, it submitted maybe a few hundred pull requests in a matter of minutes on a decent internet connection. And many of these turned out like this, and somebody merged them, and that's great, because that is code that was public on the internet for anyone to find that would not have worked with the latest version of Jade. Some people, of course, just for whatever reason, I have no idea why this person decided to close this pull request. I think I did ask them, I didn't get any response. They're just clearly not interested. So you do get maybe a third of people will do this, maybe a third of people just never get around to seeing the pull request at all. But a third of people merge that pull request, which means that you've saved them time if it's a project they're currently still working on and that they want maintained. And if it's something that they aren't really working on and don't really care about maintaining, then you've removed some code from the internet that would have been out of date. Okay, another example. I'm sort of racking for examples here for now. So there's a library called Regenerator. It's created by Facebook, and it's an open source library. And it lets you use a specific feature of ES6 in code in browsers today. And that feature is generators. So a generator might look like this. The key things on here is you've got the star after the function keyword, and that yield keyword is also new. And it can transpile that into this much more complicated code that actually does the same thing. But in order for this to work, it needs a runtime component, which is that Regenerator Runtime you can see in the middle of this code snippet. And the recommended way of including that runtime, of making that runtime available, is to somewhere in your code put this require regenerator /runtime, and that will add that runtime as a global variable in your code. But if you're publishing this to NPM, that would require everyone who installed your module to also install the regenerator module, despite the fact that you could compile at build time. So they'd have a JavaScript parser, all of the stuff to walk and transform the JavaScript syntax tree and print that back out again. when really all they need is the runtime. And the runtime is just a few hundred lines. It's hardly anything. So I published a module called Regenerator Runtime Only, which is just the runtime bit of that code and also doesn't export as a global variable. And this is much nicer. You can just put this var regenerator runtime equals require regenerator runtime only at the top of all of the files that have generators in it. And then that's your problem solved. This library is tiny to download, so you don't have that cost of downloading the whole regenerator library for every user of your project. And it works in exactly the same way, so it doesn't really have any problems. But there is a potential issue. Someone has to maintain this regenerator runtime library, and every time a new version of regenerator comes out, there needs to be a new version of regenerator runtime to match. So how do I keep it up to date? Well, I write a bot, of course. So this is, if you go to Regenerator Runtime Only, there's a domain name online, and you can see this status page for the bot. And this is checking every 10 minutes or so. It will look up on NPM and fetch the latest version of the Regenerator library. And having done that, it will see if there's already a matching Regenerator Runtime Only library that's been published. If there is, then it will just stop and go to sleep for another 10 minutes. If there isn't, if there's a new version of Regenerator out, then it will download that new version of Regenerator. It will automatically extract just the runtime component out of that. It will then run all of the tests from the main Regenerator library that are targeting the runtime components. And assuming that providing those tests pass, it will then publish a new version of Regenerator Runtime Only. If those tests fail persistently for multiple attempts, then this will start returning a 500 status code when I fetch this page, and then various alerting infrastructure will ultimately eventually send me an email to say that this is not working. So I've taken something that was something I built as a little side project in a day that I think would be useful to people, but that I wouldn't realistically have had the time to remember to maintain. And now, because of this, I don't need to find the time to maintain it. It's going to be up to date forever, well, for as long as it's relevant, realistically. And that both leaves me free to do other things, and also means that you can trust this software to be a reasonable thing for you to depend on, because it will stay up to date. So what other ideas are there? What other things could you automate? Well, a slightly sideways approach to this that I haven't talked about so far is writing plugins for your web browser. So rather than just requesting from the API, there are some simple things that might bother you about GitHub that you could fix very easily from a browser plugin. So one of these things was that I found that when I started working with people on GitHub, who I also sat with in an office and worked with in real life, I found that their real name did not match their username on GitHub, and that I knew most of these people by their real name. And that made it very hard to figure out who was saying what when I was looking through conversations in issue trackers online. I also found that from time to time I would meet someone at a conference who I had done tons of open source work with online, and they'd say, "Hi, I'm such and such." And I'd go, "Who?" And they'd go, "We worked together on this project for ages. Do you not remember me?" And the problem is that people's usernames don't match their real names. And that's fine. Some people don't want to publish their real name online, and I don't have a problem with that. But lots of people have added their real name to GitHub as well as their username. And it's right there in their profile page. It's just not displayed on the issue tracker. It's not displayed on the commits. It's not displayed on the pull requests. So I've written a little plugin. It's called GitHub Real Names. And all it does is inject some JavaScript into the page on GitHub and finds anywhere on that page where there's a username, and then goes and tries to fetch the real name for that username and replaces all of the usernames with the real names. I find it very useful. It's entirely up to you whether you think it's useful as well, but you can go and find that online, and it's actually in the Google Chrome like plugin store thing. Someone else built an interesting tool called the Open Source Report Card, and you can just Google for that, and it's fairly easy to find. And this uses the GitHub API to do a load of analysis of which languages you prefer and how prolific you are, and builds a kind of profile of you as an open source contributor, and compares you to other people and says you're similar to this person and you've done a lot of work with this person, so maybe you two are friends. And it can pick out interesting stats about what times of the week you work best, what sorts of work you like to do at different times of day. Perhaps you comment on lots of issues in the evening, but you write all of your code in the morning, for example. And it can do that kind of analysis, which is interesting. There's GetSpective, which is a fun little tool. Someone's built a kind of Facebook-style timeline, but for your GitHub activity, and you can view that. There's WhoBoard, which is it's a commercial application, I believe, but it's a full sort of Kanban-style, Trello-style dashboard on top of GitHub issues. And this is storing all of the information in GitHub. It's actually using the tags that you can assign to issues to determine which column the card should be in. And then it's moving, when you move a card from column to column, it's calling the GitHub API and changing the tags that are on that issue. So if there's one thing that I want you to take away from today's talk, it's that you should build more bots. You should automate more things. Write scripts when you need to do something to multiple repositories, like I did with Jade, and write bots when you need to keep something up to date over time, like I did with Regenerator Runtime. And some examples of the sorts of things you might be able to do is fixing deprecated features. You could build better issue tracking tools so you can keep track of the tasks and the issues and the pull requests that you need to look at. You can do things like create scripts that go and close any issues that are on any of your repositories that haven't been looked at in months. And that's a great way to figure out whether something's important or not, because if you close an issue and no one comments on it, then it probably wasn't really that big an important issue to start with. And then the ones that were important but were being neglected anyway, someone will comment and go, hey, why did you close this? You can hunt for likely errors in other projects. So for example, you could look for security bugs in people's code. You could look for undeclared variables in JavaScript. And you could try and fix those automatically for people and submit pull requests automatically that fix their code, or issues at least automatically that alert them to the problem that they have. You could even automatically patch certain security vulnerabilities. So there's a node security project, which if any of you do any node, or for that matter, really any JavaScript at all, you should definitely check this website out. And they publish a stream of security vulnerabilities that they discover in modules on NPM. And they actively go and hunt out these vulnerabilities, but they're also the best people to contact if you find a vulnerability in an NPM module. And in addition to publishing a human-readable form of this, they also publish a machine-readable form of this. So we could parse that machine-readable format and then submit pull requests to every project that depends on the module where a vulnerability was exposed to update that version to the latest version. And of course, it's still then up to the maintainer of that project to get around to merging that pull request and submitting a new version, but at least they've got something there to prompt them to do it, and it might lead to these bugs getting fixed faster. Another thing we could do is automated version management for things like peer dependencies. So NPM has a system of managing dependencies that actually works really well for 90% of use cases. So you don't tend to get the same kind of dependency hell that you get in a lot of other languages. But occasionally, you really do depend on only having one version of a specific library in your project. And that's where peer dependencies come in. They allow you to say, for a given module, so for module A, you can say this works with this range of versions of module B. And then for module C, you might also say this works with this range of versions of module B. And then it's up to the user to find a version that will work with both. And that obviously creates this kind of dependency hell and is really nasty. But one of the things we can do to alleviate that slightly is make sure that the version ranges we specify for those projects are always as wide as possible without being too wide. So we don't want to get a situation where the version ranges are too wide, because then people will install, think everything's going to work fine, and they'll just get obscure bugs in production. But if we make those ranges too narrow, then people get lots of errors on installation when, in theory, everything should just work. So if we built a bot, then we can just detect every time a new version is published. We can run the tests, and if the tests pass, we can update that version range. We can submit a pull request to update that version range and automatically keep those ranges up to date. And if any of this has inspired you to get involved with writing bots and building this kind of tooling for the open source community, or equally for use within organizations, I've very recently created this GitHub organization called Scriptit. That's where GitHub Basic lives now. But you can also, I also plan on hopefully adding other tools, and I'd love people to come and join me. So if you go to Scriptit, there's a Scriptit repository. If you comment in one of those issues, I will add you to this organization, and we can work together to automate more things on GitHub and keep more things up to date and reduce the amount of stale code that's on there. I'm Forbes, and I'm happy to take any questions.
Thank you very much. Thank you. All right, question time. Yes. Γιατί όλοι από τις γωνίες? Every time in the corners.
All right. Can you talk a little bit more about the application that you saw, the WhoBoard? Is it? Do you deploy it yourself? How does it work?
So it's. I don't know a great deal about it personally because I haven't really used it very much. But I believe it's a software as a service. So I think it's free for public repositories, and then there are paid for plans for private repositories. And yeah, it's a service, and you pay for it, I think, per repository, and then this all updates in real time as well. So you could put this on a TV screen somewhere, and it would just stay up to date, and all the cards would move around magically. So it seems like a pretty neat project management tool if you're managing large projects on GitHub.
Okay. Oh, hey. Didn't see you there.
There's too many pillars in this room.
Yeah.
So the automatic pull requests are cool. Have you considered automatic comments on Stack Overflow issues and stuff like that?
That certainly is an interesting area. I haven't looked at automating Stack Overflow. It does have an API though, so it should be possible. Yeah, I've done a bit of automating NPM. I've done a lot of automating GitHub, but I haven't looked at Stack Overflow.
Next question.
Okay.
No more questions.
But I'll be around. Oh.
There's one.
I will also be around afterwards if anyone wants to chat about anything GitHub related or JavaScript related.
Okay. Do you know if there are any issues creating bots using the GitHub API for commercial use?
It's a good question. The caveat being, I'm definitely not a lawyer. I haven't looked into this, but I believe that it's intended that you can. I would be very surprised if you can't. I think that should be fine. But obviously, yeah. I would check and look through the documentation and see if you can find. I'm sure that they'll have a list of terms and conditions, and I think they're fairly readable if I remember rightly. But yeah, I don't know for certain.
Okay, next question, yeah.
And a kind of weird question. If somebody seeing your presentation has some malicious intentions, does GitHub prevents us from this bad use of its API, for example, or it may be a bug to our bot and starting.
So it's definitely possible to generate a fair bit of spam using this API. Like one of the examples I didn't use on this presentation was a person called TJ Holloway Chuck. You may have heard of. He also had the GitHub username of Vision Media, but he all of his packages on GitHub and npm lacked the repository field in package.json, and this resulted in a warning whenever you npm installed them. It said, warning, this package does not have a repository field, and that really annoyed me and annoyed a lot of users, even though it's only really a small thing. So I went and kind of asked him, can I fix this on all of your repositories? Is it all right if I submit pull requests to every single repository to add this field in? And he foolishly said yes. So I sent to one person, I think, around about 200 pull requests in about 1 hour to add this field into every single one of those package.json files. And so nothing in GitHub flagged that and said this looks malicious. So that the controls, if there are any, are fairly lax. But I did ask permission before doing that. And if you are going to have a bot that you expect to spam one individual user, then I would say ask for permission first. And equally, I would say try and test your bots on a repository that you own first and that doesn't have any other people contributing to it, because there is a danger of that they generate pull requests that are just spammy and broken.
Okay, next question.
I saw one over there.
Oh.
Nope. I've answered it. Okay.
All right. Okay. Who's next? Who am I? Oh, there we go. Okay, I saw you now.
Hi.
Hi.
Wouldn't it be amazing if GitHub had such a functionality built in? So you could just switch on and have some warnings about your repos or whatever. Thank you.
Yeah, so it would be nice if GitHub had more functionality built in, but as with any software as a service, they have limited resources, limited numbers of engineers, and I think what's nice is that they've used some of that time to build these APIs that give us the power to build our own tooling a lot faster than they could really build their tooling. So they're obviously focused on a really wide range of platforms. They support any language you care to use. So they have very limited bandwidth for building features that are specific to a given language, like features like most of the examples I've shown on here are very specific to Node.js. So they're not going to build those kind of features. They've built a very low-level API, which gives us a lot of room to build our own higher-level APIs on top of that and experiment with different things, which I think is nice. I think it's a shame that they don't have an API for a multifile commit as a single web request, because that is a bit crazy to have that back and forth for such a common use case. But generally, I think they've given us the right tools.
Okay, next question. All right.
Have you hit rate limiting?
Yes. I have hit rate limiting. So GitHub has multiple different types of rate limiting depending on how you call the API. So if you make completely unauthenticated API requests, it will rate limit based on the IP, and it rate limits to something like 100 requests per hour or something, which is really, really low. You hit that really fast. You can get around that by just authenticating your app. If you create the application as an OAuth app, you can provide OAuth authentication without any specific user context, and that will still give you the higher rate limiting, which I think is something like 5,000 requests per hour, but I haven't looked recently. It's a lot, but it's still easy to hit. You can, one of the things to be aware of is that they don't count cached requests against that limit. So if you make a request with the appropriate headers for if modified since such and such, if that returns and says nothing has changed, then that doesn't count towards your API rate limit. So if you want to do something like polling to see if the repository has changed, you can actually do that for free. So that's what that cache file was for in the example I showed earlier. If you enable file caching, then the GitHub Basic library will automatically keep on disk a copy for every request of the request and the headers that were made and the response that was returned from the server. And then when you try and make the same request again, it will make the appropriate cached request. And that tends to help massively. And because that's on disk, it persists even if you restart your application, making changes and experimenting with things. So that's definitely worth doing.
All right, that was the last question we had. We are ready to join the two rooms. Thank you very much for your presentation.
Some